Well, it's 10:30, so I think we'll get started. Welcome everyone to this webinar, Toolbox webinar, one of a series on IPM issues, methods, research, extension. And this one is on emerging technologies in weed management systems. And our presenters are Lynn Sosnoskie from Cornell and Thierry Besançon from Rutgers. Thierry is a weed scientist and extension specialist at Rutgers and works on integrated weed management in specialty cropping systems. Lynn is an assistant professor of weed science at Cornell, specializing in weed ecology and management in veg crop systems. And I just want to acknowledge our funding before we start, but also a little housekeeping. And I guess I should say I'm Deb Grantham. I'm working with the Southern IPM Center on this webinar and other webinars. So we will do questions at the end of the presentation. If you'll use the Q&A function, that will be very helpful, and then reserve the chat function for discussion or problems, I guess. Don't have any problems though. And we will have a pre-webinar poll and a post-webinar poll, and we're just about to put up the first poll. So please fill that out. It should only take a few seconds, and then we'll move on to the presentation. So there's a pretty wide range of kind of specialty crops in the audience, and a lot of knowledgeable kind of in the middle, and the less familiar with emerging weed control technologies. And I think a lot of people in the Northeast and beyond are interested in that. So we'll also do this poll at the end and can see, hopefully we'll see some changes in knowledge. So Lynn, I will pass it over to Lynn and Thierry now.
Yep. Well, I can start, Deb, if you want, but my name is Dr. Thierry Besançon. I'm the weed science extension specialist at Rutgers University, but I'm not actually in New Jersey. I'm in North Carolina, and we have nice weather here. Deb was mentioning snow, that we don't have that right now in North Carolina. But this morning, Lynn and I will be discussing some of our work experience we conducted over the last few years with new technologies. So we'll be discussing integrating emerging technologies into weed management system, because that's what we have been focusing on our research program for the last 5 years, probably, for the first system. Next slide, please. So why are we needing to discuss this technology today? Well, weeds are still critical constraint to crop production system, especially even more in specialty crops. If you're looking across all the crop in the US, there's more herbicides that are applied to more acres than fungicide and insecticide combined together. So clearly, yes, we're still using a lot of herbicides these days, but this comes with some concerns. Number one concern for us as weed scientists is really herbicide resistance, which has been in an increasing problem over the years. And it's still, every year we keep finding new cases of herbicide resistance. Many of our specialty crops are very sensitive to potential crop injury from herbicide. And if you are like me, living in an area where in New Jersey we have dense patches of different type of crops, from grape, blueberries, veggies. When you apply an herbicide on a specific crop, you always have the risk of getting some off-target impact that may be impacting a vineyard next to your field. So we know that these specialty crops are very sensitive to off-target movement of herbicides. The last thing, which is also a problem, is that when you are looking at new herbicide, we don't have many new active ingredients. I think the last new mode of action we got for herbicide was 30 years ago. So right now, when we are getting new herbicide, actually we are more retrofitting older chemistries than really creating a new chemistry. So there is nothing really new in the pipeline. Next slide, please. The next factor, which is also very impactful for us in specialty crop, is really labor. There is a persistent workforce shortage, and it's getting worse year after year. Our labor force is aging. There is fewer young entrants, especially among migrants, which are it's a big part of our workforce in specialty crops. On the last thing is that, yes, we have rising wages and compliance costs. So labor is not only becoming rarer, but it's also becoming more expensive at the same time. So, and we still need in many of these specialty crops, we still need to get labor for weeding the field in some situation. Next slide. So when we are looking at new technologies, some of the expectations that we are that are interesting for us with these new technologies that really we are expecting this new technology to be able to reduce the chemical load. So instead of doing a broadcast herbicide application like we do these days, maybe we can have technologies that can help us to target individual plants instead of doing broadcast application. We can integrate these new weed management strategies, these new technologies in our already existing management strategies. So we can combine mechanical and optical approach for better weed management. In addition, when we sum of this technology, not all of them, but with some of this technology, we can also improve our herbicide resistance management by diversifying the selection pressure, not just relying on herbicide, but also relying on other techniques that may help controlling the weed. And the last thing, which is really important as well, is that many of these new technologies will also support regulatory compliance, especially by aligning with Endangered Species Act mitigation strategies. Next slide. So actually, many of these new technologies will address these limitations that I just described. And for today, we'll be focusing our attention on 3 different types of technology. The first one is really autonomous mechanical weeding. So that's probably the lowest level of technological improvement. That will be the first one we'll be discussing, but this one is really, it will minimize the labor input. That's many of these technologies do not require herbicide. It's really mechanical weeding, automated mechanical weeding. The second one is really the use of artificial intelligence in sprayers, so which gives us a capacity of detecting weeds in real time and to apply some method of control to individual plants. And the last one is thermal weeding. Under thermal weeding, I'm grouping a lot of different technologies, from very simple technology like electricity up to something more advanced like the use of laser combined with artificial intelligence for managing weeds. So with this technology, thermal weeding, you don't use any chemical at all. So again, the overall, the goal of moving with these technologies, moving forward with this technology, is really to reduce environmental load of pesticide, improve the crop safety by being more precise when we apply pesticide, limiting resistance pressure, reducing resistance pressure. And with many of these technologies can be compatible with organic system as well. Next slide. So we'll be starting with basically the less advanced technology. It's still advanced, but it's probably less advanced in the sense that we are not using artificial intelligence with this one, which is looking at autonomous mechanical weeders and mowers. So Lynn and I, we got the opportunity a few years ago to purchase the most basic type of robot, which is a Nayo hose. Nayo is a French company, and at this time they were trying to penetrate the US market. So they were really interested working with people like us. So the Nayo hose is a small, versatile farming robot. It's fully electric. It has a relatively moderate field capacity, 1/4 of an acre per hour, but it can be running up to 8 hours on batteries. Something interesting with this robot is that, yes, you need to get still, I mean, you cannot just be relying on GPS when you want to position the robot in the field. You need to rely on additional technology called RTK, real-time kinematic, for really giving you the centimetric precision that we need when we do agriculture. So this robot, you have two videos, you can see it seeding, but you can also see it later when, after it's done seeding, creating the map of the field. The robot can come back later for weeding between the rows fully autonomously. Next slide. So we did a number of trials, and I don't want to go in length through this trial because, yes, we have been working for the last 4 years with this robot. But just to give you this slide, looking at an experimentation we conducted on sweet corn, it was in 2024 in New Jersey, on real different technology where we're looking at using herbicide, but also using the night hose alone, either weekly or bi-weekly, but also combined with a pre-emergence herbicide. And we learned quite a few things regarding the use of this robot, is that if you really want this robot to be effective, it's really a good solution to integrate them with residual herbicide or plan for frequent weekly passes for matching what you may expect from a standard pre-emergence and post-emergence herbicide programs. So clearly, yes, I mean, it's really important for this mechanical control, for this autonomous mechanical control to reduce the weed pressure to get these robot efficient enough for controlling the weeds. It's something that, I mean, when you're working with this kind of robot, you want to avoid to work with this robot in low canopy crops. I've been testing it in cabbage, and we had some significant injury on the cabbage as well. But when we're working on sweet corn, on edamame, I mean, we obtained some very interesting results with minimal yield losses in these crops. On one disadvantage of this kind of technology, when you're looking at mechanical control, it's really good for controlling broadleaf weed species. We had some pigweed. It was doing a decent job at controlling the pigweed, but it's not so efficient at controlling grasses. So that was one of the inconvenience. The other one being that you probably do an excellent job at controlling the weed between the rows of the crop, but the robot doesn't do a good job at controlling weeds that are growing within the planting line. So that's another problem that we observe with this kind of technology. So when we are looking at all the benefits of using this kind of small robot, one was to really reduce herbicide use on labor through precise automated cultivation. We didn't need to use post-emergence herbicide. We just rely on pre-emergence herbicide followed by cultivation. It's consistent, it's repeatable control, compatible with organic system. On one advantage of this technology compared to many other technologies is that it's relatively inexpensive compared to technologies that we'll be discussing later. It's still expensive, but it's way less expensive than some of the more advanced technologies that we'll be discussing today. Some of the challenges that we observed using this kind of autonomous platform is that, yes, there is really, as I mentioned before, there is limited in-row weed control, and it's not adapted to low canopy crops. There is strong dependence on soil condition and timing. It's working well on my New Jersey sandy soil, but Lynn got some different opinion regarding the use of this robot under rocky soil, where it's less efficient clearly when you have this kind of soil. It's also require a lot of soil preparation. You really need to get a flat surface, smooth flat surface to get the robot functioning at its best capacity. And it has lower capacity under high weed pressure or suboptimal condition, like, if you don't have a good field preparation, that may significantly affect the capacity of this robot for weeding. So it's really an effective solution, but it has to be well integrated with other solutions, and it cannot be really considered to be a standalone solution by itself. Next slide. So in the same family, I didn't explain on this one, but I just want to give you another look of other technologies that are also functioning with autonomous platform, GPS RTK guided platform. This is from the same company. This is a TED robot, and actually that's a robot that has been specifically designed for working in vineyards. Next slide. So we had a demonstration 2 years ago, actually, in Jersey, and Lynn had the same experimentation, same demonstration in New York. So you can see it right here in action in a vineyard. It's really cultivating, it's mechanical cultivation of the ground, but at the same time, it's also doing some pruning of the vine. So it's combining these two applications at the same time, and again, it's fully autonomous. It knows exactly where the vine is located, and there is no human control of the robot when it's working in the field. Next slide, please. So different type of robot. On Lynn can probably talk more about this one because she has definitely more experience with this one. It's a Bonsai Amiga, which is a kind of, it's a it's an autonomous platform that can be used with a diversity of tools. And I think it's really interesting to show this one because it was a demonstration at FIRA USA in California, and they were showing this platform, which is fully autonomous again, but it was combined with a mower. So that was allowing autonomous mowing between the rows in gray, but that can be used in other cropping system as well. So that's something that I think Lynn can discuss more than me on this one. She has more experience, but that's a very interesting approach as well for getting this autonomous mowing in action in the field. Next slide, please. So a little bit more advanced technology. On this one, we'll be dealing with vision guided on artificial intelligence precision sprayer. So we are coming from something relatively basics, which is just mechanical cultural weed control, to moving to something a little bit more advanced using artificial intelligence or vision detection of the weeds. Next slide. So when we're looking at targeted spray systems, there is two different type of systems. There is one system where you can detect green on brown, so you're detecting green vegetation on a brown soil background. So it's really detecting green plants against bare soil background, and you're triggering. The system will be triggering spraying only where vegetation is detected. So it's really best suited for low canopy or bare ground condition. The other system, which is more advanced, is really detecting green on green. So separating two different types of green, the green from the vegetation, from the crops, from the green from the weeds. So this system can differentiate weeds from crop plant within canopy. They will be combining cameras on artificial intelligence, using algorithm for identifying the crop, identifying the weeds, on targeting herbicide application where the weeds are located by artificial intelligence. So this kind of system have higher technical complexity, and they require a lot more computing power for really being able to distinguish between the crop and the weeds. Next slide. So one advantage of this targeted spray system is that you really have real-time weed detection. And I think what is fascinating for me is that, yes, we are moving from strategies where we are doing broadcast herbicide application to system where we can really individualize herbicide application. We can really apply herbicide to individual weeds. So some of the benefits associated with targeted spray system is really reducing the use of herbicide. You can expect depending on the weed pressure, depending on crops, you can expect between 40 and 90% reduction of herbicide use. You can definitely improve crop safety by avoiding to spray herbicide on the crop, even if it's labeled for a specific crop. And potentially, we're not yet there, but potentially we can expand chemical option by using new chemistries that are not labeled for use on a specific crop because of potential crop injury. Environmental and regulatory impact, clearly with this kind of technology, because we are putting way less herbicide in the environment, we can potentially lower drift on the risk of volatilization. And again, we can mitigate off-target movement, which is something which is really interesting, especially regarding the Endangered Species Act. So it can be considered as a mitigation strategies for minimizing pesticide upload in the environment. Next slide, please. So the first system, more basic system that I will be discussing now is really green on brown on Lynn and I. We have been working with the weed IT system. It's an optically guided sprayer based on weed detection using the weed IT system. So we mounted it on a quad system. We have been using it in High Bush Blueberry in New Jersey, and we use it as well in grape in New York. So the way it's working, next slide, please, Lynn. The way it's working is that you have a system which is emitting some blue light. The blue light will be absorbed by the chlorophyll of the plant. And in response, the chlorophyll will produce near-infrared fluorescence, which will be detected by the sensor. So the sensor will be detecting chlorophyll and will apply, will be connected to a nozzle, and the nozzle will apply herbicide where chlorophyll has been detected. Next slide. So we did some work comparing this weed IT system with a traditional backpack broadcast application. That's a study that Lynn conducted on horseweed in New York, looking at 3 different rates of glufosinate applied with a backpack or with a vision guided using the weed IT system. And clearly there was no significant difference in terms of weed control biomass, horseweed biomass production by the end of the season between these two systems. So we had the same level of weed control using the weed IT system compared to a broadcast application with the backpack sprayer. Next slide. In blueberry, we did the same system with bonded application on using the weed IT, and something which is really interesting for me in blueberry is that we are not working on a flat surface. We are working on a 3-dimensional surface because all the blueberries are hilled. You're planting blueberries, I mean, for diverse reasons, mostly for water access. And we are planting the blueberries on hill. So when you do that, clearly, yes, I mean, the weed IT, especially on the side of the hill was as efficient as a bonded application. Now, when you're looking at the top of the hill, we had less access, we had less spray applied on top of the hill, either with the bonded application, but also with the weed IT system. So because we have this 3-dimensional structure in blueberry, it's complicating our weed management, not just for bonded application, but also when you're using the weed IT system. Next slide. So something which is really interesting, that's a comparison between the study that Lynn conducted in grape and the studies that I conducted in blueberry. The red line is a vision-guided sprayer. You're looking at crop injury. So in red, the vision-guided sprayer, the weed IT system. In black, the bonded system. On clearly, I mean, in grape, we significantly reduce the amount of injury when we use a weed IT system as compared to the bonded application. Now, if you're looking at what's going on in blueberry, that's a different story. In blueberry, because I mean, you rely on the production of new cane from the crown of the blueberry. Clearly, we got significant greater injury, especially early on in the season, with the weed IT system as compared to the bonded application. And one of the system, something which is important to consider is that the weed IT system cannot differentiate between the chlorophyll of emerging blueberry on weedy, chlorophyll from the weed. So it was considering basically these very short shoots coming from the crown as weeds, and that's when we started to get a lot more injury early in the season. So that's one of the limitations. It may be working well on grape where you don't need to get new shoots coming from the base from the trunk, but in blueberry where you actually rely on the production of new shoots for rejuvenating the crop, that's a problem. Next slide, please. So based on this result, I mean, we got an idea of, Lynn mostly got the idea of using targeted spraying for grape sucker control. So If we can see on spray the weed, can we see on spray other undesirable tissues like sucker in grape? So that's something which is interesting, because if we can do it, we can reduce the need for on labor, and we may prevent physical damage to vines from mechanical practices. In addition, if you can automate the application of herbicide for suckering, you can also decrease the time which is required for conducting these kind of operations. Next slide, please. So we conducted some experimentation again in New York and New Jersey. The weed IT system, which achieve 88 to 98% sucker control, matching what you will get with a standard herbicide application with a wand, or what you will get from manually doing it with a crew in the field. It reduced, using the weed IT help reducing the suckering time on the need for labor. And actually, Lynn is working to the next step, which is trying to fully autonomize suckering by mounting the weed IT system on the autonomous Amiga platform that I showed you previously in the video. So yes, this way we can get a fully autonomous and efficient system for sucker control. Next slide, please. So when the weed IT system in perennial crops, that's where we've been evaluating it. When does it work best? Well, it's best fitted for situation where you have low to moderate weed pressure. So you still, again, pretty much like what we discussed before with the autonomous mechanical cultivation, you really need to reduce your initial weed pressure by using some pre-emergence residual herbicide. Otherwise, the system will be overwhelmed, and there will be no difference between using the weed IT system as compared to broadcast application. It's working well on small actively growing weeds. On its well-managed rows, you need to have well-managed rows with limited in-row complexity for getting this type of sprayer working efficiently. Where you have to be cautious, yes, when you have high weed densities or large weeds, this system is not as efficient, and definitely you don't see much of a difference compared to a broadcast application. When you have new plantings with emerging crop tissue, like what I mentioned in for the blueberries, that may be a problem as well, because the system cannot differentiate between the chlorophyll from weeds and the chlorophyll from the crop. When you have dense canopy or irregular growth near the base, that's also a problem as well. So it's really most effective. This kind of weed IT system is really most effective as a precision post-emergence tool when it can be integrated with residual herbicides. Next slide. So now, moving to a more complex system, we are looking at green on green, and we'll be discussing our experience with the Verdant robotics aim and applied technology. So this one is more complex because you're not just using a sensor which is detecting the chlorophyll, but now you're integrating cameras that are scanning the soil, scanning the ground, and combining it with artificial intelligence for detecting the weeds. So you have high resolution cameras that will be continuously scanning the crop canopy or the soil. You have artificial intelligence algorithms that will distinguish the weed from the crops. And with this system, with the Verdant robotic system, you have spray nozzles that are mounted on turrets that can be oriented towards the weed and spray herbicide directly on top of the weeds. With this system, the application rate can also vary according to weed presence and weed development. Next slide, please. So we did in 2025, we did some evaluation with a demonstration unit. We didn't have a commercial unit, so we had a demonstration unit which was mounted again on a Farm NG Amiga, a Bonsai Amiga, sorry. So we did some work in 2025 with a system in spinach that we planted in New Jersey in fall. So we had different type of treatment. Yes. Can you click? Yes, Lynn, thank you. So we had an untreated control. We had a traditional herbicide, dual magnum on spinade being our post-emergence herbicide. We applied them with a broadcast application with a boom sprayer. We had again the dual magnum pre-emergence followed by spinade, but this time instead of being broadcast, we applied the spinade with the Verdant aim on applying system. And we had a situation at last treatment where we didn't have any pre-emergence herbicide. We just use a spinade herbicide post-emergence applied with the Verdant aim on apply system. Next slide. So when you're looking at weed coverage, clearly it's really a good idea with this system to get to still get your pre-emergence herbicide. If you're looking at the picture on the left, it is your untreated control. You can see the density of weeds, and actually when you're looking completely on the right, that's where we applied the spinade with the Verdant system with the aim on applying, but where we didn't put any pre-emergence, you don't see any difference in terms of weed coverage. Where we put S-metochlor pre-emergence, we got decent weed control, and we are able to really control the weed post-emergence with the aim on apply technology. Next slide. What was really interesting, and I think I have a picture a little bit later, but what was really interesting looking at the difference between the broadcast and the targeted application was really to look at spinach tolerance, especially looking at visual stunting. We had 2 different dates, 30 days after application, 40 days after application. On it, both cases, we observed significantly greater stunting associated with the broadcast application than we observed when we did the aim on applying targeted application. Why was it the case? Mostly because the herbicide that we use, spinade, post-emergence, can be phytotoxic when you apply it at temperatures that are above 80 Fahrenheit, which was the case. I mean, we planted in fall. I mean, we did this application probably in late August. And yes, in New Jersey, late August, you can still have days when the temperature are above 80 degrees. So we didn't see this kind of phytotoxicity when we did the targeted application. Why? Because we just concentrated the herbicide on the weed without affecting the crop. So we got a similar level of weed control, but we significantly improved crop safety using the AI targeted application. Next slide, which ultimately translated in excellent result for yield. We had 2 different picking dates, 40 days and 70 days after planting. At the first date, the aim on applied technology gave us 155% greater yield than the broadcast application. The second date with the aim on applied, as long as we had a pre-emergence herbicide upfront, we got 67% greater yield as compared to the broadcast application. And even if you have relatively high weed pressure, which was the case when we didn't put any pre-emergence herbicide, you still improve spinach yield when you used the aim on applied technology as compared to a broadcast application. So I said, I mean, next slide, Lynn. I said that the picture is sometimes worse, and clearly you can see the difference between these 2 technology. On the left side, you look at spinade applied as a broadcast application. We had 40% stunting on spinach. And on the right side, you look at the same herbicide, but this time applied with aim on applied, and we only got 3% stunting. So really, we improved crop tolerance, we limited stunting, and ultimately we improved our crop yield using the aim on applied technology and still getting the same level of control. Next slide. So there is still some constraint when you're looking at this new technology based on vision guided spraying. The first one is really regulatory. Our label, our herbicide label are designed for broadcast application. So it's unclear if they can fit for targeted spraying application. There's always a risk of over or under application on potential residue issues because there is no clear pathway right now regarding the label on how we can use some of these herbicide, specifically for targeted application. Operational application, yes, the weed pressure is often underestimated. So this kind of system is really working the best, again, when you can have a residual herbicide upfront, when you can reduce your weed pressure. And if that's not the case, they will not be as efficient. Spray volume and logistics, the mixing, the clean out are harder to manage in these systems than on broadcast application. Equipment setup is also challenging. You need to get some specific type of boom, of nozzle. You need to get excellent boom stability. So again, the field condition will be really important with this system to be to function optimally for weed control. So boom stability is critical with this system. Next slide, please. So where does it fit? The strength of the AMON applied technology is that it can enable plant level post-targeting within the canopy of the crop. You can maintain weed control while improving crop safety with this kind of system, but there is some key consideration as well. It must be integrated with residual herbicide, as I mentioned before, and the performance will depend on application setup and condition as well. On one of the big issue too is that it does, I mentioned earlier that herbicide resistance was an issue, but this system does not address herbicide resistance on its own because you're still using the same herbicide that may lead to herbicide resistance. So it's a high precision tool that works best within a well-managed system overall. Next slide. And I think, yes, I think Lynn will be discussing the next slide. So I will let her discuss what we have.
Thank you so much, Thierry, and thank you everyone for attending today, and thank you for the invitation to speak. I am going to be talking about our thermal technology that we've been investigating, electric weeders and laser weeders. Before I get on to that, Thierry had brought up that we are doing some work with the Bonsai Amiga. We have been we hope to be awarded in a grant from the New York Wine and Grape Foundation. They have been supporting some of our research looking at autonomous weed control and autonomous sucker control to actually investigate autonomous mowing in vineyard systems. And one of those technologies is actually going to be working with Terry Bates out at our Cornell research station to mount a mower on our Amiga system and autonomously mow some of those vineyard blocks. And like Thierry said, we have been doing work with the Weed It system to automate spraying in vineyards, again, out at our Clarell station, which is out in Western New York in grapes. And we did successfully put our Weed It on the autonomous Amiga robot in 2025, and we're able to spray a research block, and we actually got better sucker control using that fully automated system than we did with having a person on an ATV with a spray wand. So those results are going to be submitted for publication soon. But I'm going to switch and I'm going to talk to you about electric weeding and laser weeding. Why didn't I not switch? Okay, first off, electrical weeding. This is actually not new technology. The first patents for electrical weeding were issued in the 1890s, and it was actively explored in sugar beets in the 1970s and the 1980s. It has seen a resurgence in interest, in part due to the growing issues with herbicide resistance, particularly in our annual cropping systems. Now, electrical weeding works exactly like it sounds like. You have physical contact of a target plant, in this case, the weeds, with high voltage electrodes, and that establishes a current flow through the plant. The flow of that energy through the plant generates heat that disrupts cells, and that leads to the tissues wilting and dying. In some instances, this current can actually pass through the crown and into the roots, resulting in what you could call systemic damage. It's touted as being sustainable because it's herbicide free and we don't have soil disturbance. So the first electrical weeding tool is one I'm going to talk about that's designed for annual crops. That is the Weed Zapper, and this is produced in the United States by Old School Manufacturing. This is a tractor mounted unit. You've got a generator at the back. It's operated by the power takeoff unit. And basically it produces electricity that charges a front mounted copper bar, and any weeds that are above the crop canopy that come into contact with the bar are electrocuted. And I'm going to show you a video in the next slide. So this is Western New York. This is a dry bean field where horseweed, mare's tail, Canyza canadensis got away from the grower early in the season. He didn't have anything, obviously, post-emergence that's going to be able to take care of those very large horseweed plants in his dry bean. So he borrowed a neighbor's weed zapper and ran the unit. And after about 2 passes through the field, we got canopy closure and we had really successful control of this weed. We have looked at it in a variety of crops, both annual agronomic row crops as well as some specialty crops. This is some data I collected from the first year we evaluated it in soybean. This was 7 days after treatment. We looked at pigweed, velvet leaf, and ragweed that wasn't electrocuted and that was electrocuted. Those weeds that we did have the weed zapper run through the field, we saw a 61 to 84% reduction in the biomass of that above ground tissue. And I didn't show this data, but ultimately this led to a 67 to 88% reduction in weed seed production from these species. So not only did we have, again, reducing this biomass that is competing with the crop, but we're actually reducing its reproductive potential and the potential for weed seeds to go back into the seed bank. Now, I showed you the results from velvet leaf, ragweed, and pigweed. It is not equally effective against all species. In particular, grasses and perennials are a little more difficult to control with electrical weeding in my studies. So this is a picture, again, from a soybean field, an organic soybean field in Western New York. You can see we have a very significant foxtail issue. The first picture was July 21, before we ran the electrical weeder. The second picture was like within a day of electrical weeding. And we thought, man, we did a great job. Look at this. We are fantastic. But then end of season, we just have noticed that our upright, very succulent broadleaf weed species are more easily controlled than the grasses, in part because those broadleaf weeds, they aren't as droopy as those grasses. They have more water content in their tissues. So the electrode is in contact with these weeds longer, and there's just more moisture for current conductivity. Now, we didn't see any injury in our soybeans, so we tried it in beets, our red beets. We have a large red beet industry in New York. And I'm going to tell you, we actually saw some damage to the red beets, particularly in dry, sandy soils. And when those weeds were directly in line in the row with the beets themselves. So you can see on the right, there is a lamb's quarters plant that was really well controlled with the electrical weeder, but we also controlled the beets on either side of that weed. And under those dry, sandy conditions, those beet roots were really starting to develop. Basically, the electricity took the path of least resistance and it went through the beet roots, and that resulted in beet injury and death. And this is what you can see, where we had weeds that directly adjacent in line with the beets themselves. We got the damage to those taproots. Sometimes we just killed the beet root entirely, or even if we didn't kill the beet root, it started to push out additional fibrous roots, and that affects, sizing up of this crop. We did see that sometimes if we got the weed was just right outside of the crop row, is that we got control of the weed without getting the damage to the crop itself. So proximity in this instance plays a significant role. Now, I have a colleague in Michigan State who did the same study in carrots and didn't see the same damage. She saw some foliar injury with the electrodes, but she didn't see any root damage. She didn't see any yield loss. Much like us, the electrical weeding cut pigweed seed production and germination. She didn't see any meaningful impacts on soil microbial communities. That's a big question we get. If this electricity is moving through the soil, are we causing damage to the microbes or the microarthropods? It also reduced the need for hand weeding and was cheaper than hand weeding. But I think the summary of both of these results suggest it's going to be very situational dependent, and there's still a lot more work to do. Now, we have looked at electrical weeding using a different type of weeder. This is called a continuous contact weeder instead of the spark discharge, which was the old school manufacturing weed zapper system. This is our e-coffee unit from the Zaso company that is designed for orchards. Again, it is tractor mounted, generator powered by the PTO. It charges the electrodes, which are underneath that applicator. In this instance, instead of waiting for weeds to get above the canopy, we're going underneath the canopy of our orchards, right alongside the planted tree row. Now, it doesn't look like it's doing much when we're running it immediately. We're not seeing the arcing or sparking, certainly in our situation in New York, but we are getting damage. You can see at 7 days after treatment and 21 days after treatment, the type of weed control we were able to achieve. Now, I have a graduate student who has been conducting research trials in apples for 2 to 3 years, and these are perennial cropping, perennial weeds in a perennial cropping system. And what we have seen is excellent season-long weed control using our Zaso electrical weeder in this system. That's our Zaso operating in an organic apple block down in Ithaca, New York. You can see some of the perennial weeds we have present, and you can see the type of weed control. I think that was 2 to 3 weeks after she had run the unit. Again, we are seeing substantial suppression of perennial weeds. This is average Canada thistle biomass where we ran the electrical weeder versus where we had an untreated check. Aaliyah, in addition to showing the efficacy against our weeds in our apple production systems, has also shown that we're not seeing significant impacts on our microbial communities. We're not seeing significant impacts on our microarthropod communities in those production environments. As opposed to cultivation, we're seeing no impacts on soil stability, aggregate potential. So we have very good soil health metrics where we're using the electrical weeding in our perennial production systems. Zaso is building some prototypes to bring that same technology into annual row crop systems. So instead of going over the top of the row, can we just get those newly emerging weeds in between the rows? And we conducted a trial using my Zaso electric weeder. I don't have this prototype just yet, but we planted corn and we planted soybean, and we just said, okay, let's run the electrical weeder. Let's not run the electrical weeder. Let's just have an untreated check and electrically weeded zones that we applied at the V2 to V3 stage. And let's see what kind of weed control we can get and what kind of crop responses we can get. And what we found is using that electrical weeder, we were really successful at removing the weeds between our simulated rows. So that area alongside the planted strips that came into contact with the electrical weeder, a phenomenal weed suppression compared to our non-treated check. Where we now, much like Thierry said, with the NIO-Oz, and this technology, not getting the weeds within the row. We, much like this, we didn't have the electrical weeder. It can't get the weeds in the row. And so we didn't see any difference in weed cover between our electrically weeded system and our non-treated check. However, even though we ended up leaving some weeds in the row, just removing the weeds alongside of the planted strip on either side of the planted strip, we got a 47% increase in the corn biomass. So just removing some of that competition gave us a significant crop boost. And we saw something very similar with our soybeans. Again, these are preliminary responses, but showing that, and maybe instead of using inter-row cultivation, we can use this electrical weeding in place of that very disruptive soil disturbance to manage weeds. We're still going to need some tool or technology for controlling the weeds in the row, but this does give us another opportunity, another tool for the toolbox. So electrical weeding can prevent or reduce yield loss, particularly when we have early intervention. By removing the weeds, certainly reducing yield loss is important, but it might also benefit us because if we can reduce that weed interference at harvest, we can actually improve machinery, such as our harvest equipment through the field. And that is going to also help us preserve yields because we're not going to have the loss due to stoppages or breakdowns of the equipment. It can help us prevent weed seed production and then return to the field. And in some fields where we have herbicide-resistant Palmer amaranth or water hemp, I've made the suggestion to some growers is, do you have a neighbor that has a weed zapper? Before your soybean canopy closes, maybe get in there with the electrical weeder. You're not necessarily going to impact the yields because you're getting in late, but man, you might make your harvest more efficient, and you might be able to reduce that seed production. Again, this technology, like any technology, needs to be part of an effective and diverse management program. And we're still continuing trials in 2026 in both apples, in grapes, and in our annual crops to evaluate the technology. So the last technology we're going to talk about is probably the biggest and the baddest form of thermal weeding, which is laser weeding. So much like the precision herbicide applications that Thierry talked about, our laser weeding technology uses a lot of the same strategy. It is detecting the weeds, discriminating the weeds from the crops, and then using highly focused laser beams. Up to this point, mostly CO2. Now we're moving into diode lasers to actually zap the weeds, target the weeds with this high energy to control them. So this is just an example. The healthy weed before the laser is applied to it, immediately after the laser is applied to it. These laser technologies really target the meristems, those growing points of the plant. And if you get in early enough, that can prevent weed regrowth. There are companies operating in the space, primarily in Europe, such as Weedbot and Escarda. But the biggest player in the sector is going to be Carbon Robotics. This is an American company. It was founded in Seattle, Washington in 2018. They don't really release how many units they have in operation, but we do know there's hundreds of customers operating in 14 countries, and they've raised up to approximately $270 million in capital investments. Again, these newest G2 weeding modules have diode lasers. They still have the high resolution cameras, dual NVIDIA GPUs, and LED lighting to basically illuminate the bed top that allows those cameras to work most effectively to say, this is a weed, this is the crop, and then target the laser beams accordingly. So this is the Carbon Robotics. This was a research and demonstration unit in operation out in California at one of the FIRA USA conferences. And what you're seeing is that bright light is the light that's illuminating the bed top so the cameras can see the weeds and see the crop. And those little pinpoints of light, those are the laser beams actually targeting the individual weeds between the lettuce rows. This is a hyper precise technology on the right. That is lettuce at the one leaf stage, and that is a weed that is targeted directly adjacent, within millimeters of that onion. I'm sorry, I said lettuce, that's an onion plant, within millimeters of that one leaf onion plant. So we have conducted trials with carbon robotics in multiple crops in both New York and New Jersey. I'm going to just focus on spinach really quickly, and I'm actually going to focus on just the New York results. We wanted to compare laser weeding alone versus a herbicide program, or combining the laser weeder with the herbicide program. Across both of our trials in both New Jersey and New York, I'm just going to tell you, laser weeding was as good or better than our standard pre and post emergence herbicide programs for weed control. And much like Thierry saw with the spinach, with the aim and apply system in New Jersey, our crop injury was reduced and our yields were increased with the laser weeding technology. This is just showing you the weed control from the New York spinach trial. This is weed biomass at end of season. So this was collected at crop harvest. And basically, the laser weeding alone or in combination with the pre-emergence herbicide reduced the weed biomass even relative to our conventional pre-emergence herbicide program, and certainly compared to our non-treated check. And this resulted in improved crop yields, but improved crop yields really where we just had the laser weeding alone. So again, like Thierry saw with the herbicides in his spinach trials in New Jersey, we saw significant injury where we had our herbicide program. In this case, we had a very unique situation that resulted in crop damage from our pre-emergence herbicides, whether they were used alone or with the laser weeder. We had planted our crop. We then had an intense downpour where we got over an inch of rain in a very short period of time. Then our temperatures went above 90 degrees. Basically, that soil structure was disrupted and it turned into concrete. And where we had our pre-emergence herbicides, our spinach crop had a much more difficult time getting out of the ground because it was trying to metabolize the herbicide as well as break through the crust. So we had significant crop injury. Where we had the laser weeding alone, our crop was able to get out of the ground. We had less stunting, and this increased our yields 39 to 56% by end of season. We did conduct a trial last year in onions. We were actually injured okay. Could we not only control weeds and improve vigor, could we also, with this improved vigor, would that maybe reduce the damage from onion thrips and stem phyllium leaf blight? So if we had the more vigorous crop, is it going to be less sensitive to other pests and pathogens? So we had, this was work conducted with Christy Hopeting and Brian Nault at Cornell University, and we worked in a grower field under commercial conditions, and we had our high herbicide program, full rates of Prowl, H2O, and Outlook. And this is a program that we would use if we have high weed pressure systems, which this grower does. The medium herbicide program, which had reduced pendimethalin and dimethenamide, this is his goal. This is what he wants to get to. By using the laser weeder, can he reduce his pre-emergence herbicides and still maintain effective weed control? And then we did a lower. Can we take it even lower, and can we still get weed control success? It didn't completely eliminate our need for post-emergence herbicides, but I'm going to tell you the incorporation of the laser weeding unit in our medium and low programs, we were able to achieve the same amount of weed control as we did where we had our high herbicide program in place. So this is the commercial unit that we use. This is in the grower's field. This is the original G1 laser weeder. Again, you can see the little puffs of smoke where it's actually hitting the weeds in between the onions. Again, this is an older system. It uses CO2 lasers. The newest models are diode lasers, a little bit more effective, a little bit less energy use, a little bit lighter. So I'm not going to go into too many details, but just to show you the differences in what changing that herbicide program did. We did have a little bit more weed escapes in our medium and low herbicide program from our pre-emergence herbicide applications, but our post-emergence herbicides partnered with the laser weeder, we were able to control them effectively. On the left, you can see what that weed pressure looked like if we didn't do anything. What I really want you to focus on is, much like we talked about with our aim and apply system and with our previous laser weeding trial, is the improvement in crop vigor if we took some of those herbicides out of the equation and relied on alternative technology for weed control. We got substantially improved crop growth and development in our medium herbicide program, which is what the grower wants to do. This is his goal, as well as the low herbicide program. And this just shows you some of the differences in crop growth on June 7th, as well as July 7th between the high, medium, and low program. Ultimately, this did affect the yields that we saw end of season. In those low and medium programs, we had 21 to 23% more medium-sized bulbs. The low program, we saw more jumbo bulbs, but at the same time, we had greater bulb rot in that system. We had a 42% increase in the bulb rot where we had those jumbo bulbs. Now, we thought we would have reduced, disease development. We thought we'd have reduced impacts of the thrips, and that wasn't the case. We didn't have high thrip problems in 2025. However, the stemphillium leaf blight incidence, contrary to what we thought, we actually had greater stemphillium leaf blight in the low and the medium herbicide programs. It wasn't significant, but it was there. And what we think happened is we had more succulent tissue in the low and medium program. We had denser canopies, and that actually increased disease development. Didn't have an impact on yields, but it's something that we definitely need to pay attention to. We need to be focusing more on some of these downstream effects of the technology. Some thoughts about laser weeding. It's heavy and slow equipment. The cameras, the processors, the cooling system, that all adds weight, and that could lead to soil compaction concerns. Those new units are lighter, but we still need a certain amount of weight for stability for the targeting. Carbon Robotics now has their large plant model and better processors in the G200 unit, so that will improve speeds, or should improve speeds of performance. It is energy intensive, but targeted applications should improve efficiency, and narrow beams are going to use less energy, but that could also reduce the efficacy with larger weeds. We do see smaller treatment areas. So again, reducing non-target impacts of technology. Again, it doesn't disturb the soil, but compaction could be a concern. I am concerned with this vision-guided technology about weed adaptations. What Thierry talked about, herbicide resistance. We're still using herbicides. And so is that truly going to, how is that going to impact the development of resistance? Are we actually going to reduce that risk if we're still relying on the same technology? But I'm also worried about crop mimicry with these camera-based systems. Basically, we know that image-based weed control can select for weeds that mimic crops, and then those weeds would escape detection, and then they would become dominant with this system. So could camera-based systems over time, could we see reduced control because we are shifting our population to harder to manage weed populations or communities because they look more like the crop than not? The tech sector is growing. If you are interested, I recommend going to the mixingbowlhub.com, and they just keep updating this map of all of the companies that are in the crop robotics landscape. Terry and I couldn't even talk about a fraction of them. Just some considerations for tech adoption going forward. These tools can be expensive. You know, some of the smaller robots, autonomous robots, maybe $20,000. My Weed It system was, when I purchased it, was about $15,000. My electrical weeder was $70,000, but that cost has certainly gone up. You know, the laser weeders, the precision sprayers are maybe $300,000 to $750,000. The original G1 laser weeders are over $1 million. So the investment is a lot, and we've got to think about accessibility and who's out there working for the smaller to mid-sized farm with more affordable units. But there's subscription fees, equipment upgrades, parts availability that all need to be factored into this. You have to be thinking about the agronomic fit. Does you have the value to adopt this technology? We have 5 laser weeders in New York, and they're all in onions, which are an exceptionally high value crop with few other tools other than hand weeding for weed management that aren't going to cause crop injury. You have to be thinking about size and shape of your fields, your soil and surface conditions, slopes, before investing in technology, as well as operator skills, training requirements, calibration time. These tools come with learning curves. You need to be thinking about how well they're going to work. Do they have the models designed for your crop if you're going to be using the AI-based systems? Thinking about the equipment you already have, and are these new tools going to be compatible with it, as well as your goals for the system? If you're interested in automating more of your farm, you know, then this technology certainly becomes of more interest. And then there's the regulatory and environmental benefits. Terry talked about, we don't have the labels specifically addressing precision herbicide applications. But at the same time, we know that the technology comes with the potential for reduced herbicide use, off-target movement, which could lead to increased market access and the ability to access more diverse certification programs. This is the end of our talk. I want to take time to thank all of the people who have sponsored our research. Terry and I are very grateful to our commodity groups within New York and within New Jersey. The New York vegetable growers, the grape growers, and the apple growers have supported our research, as well as the New Jersey vegetable, cranberry, and blueberry growers. We have received support from the United States Department of Agriculture, from the IR4 project, and from the companies themselves who have donated the use of the equipment, such as the laser weeder, such as some of the precision sprayers. We are very grateful. We realize that a lot of this technology is new, it's large, it's expensive, but we also recognize that this industry is changing. More and more players are coming on the market. And Terry and I and our colleagues are very interested specifically in evaluating this technology, the good and the bad, so that as growers are interested in adopting, we can give them our own, science-based opinions of their performance and value.
Wow, thank you very much, Lynn and Thierry. That was a really interesting presentation, and it looks like pretty fun field work too. So I think Kevin's going to put up a poll right now that all of you participants can respond to. I hope you will. And we have a few questions. Actually, in your last slides there, Lynn, you spoke to some of the questions which have to do with costs, and will Joe average farmer be able to afford to purchase or rent this equipment? So I'm not sure if anyone has other questions about that, but if you do, please use the Q&A for any of your questions. And then I'm just going to read one of them to you. Do the green on brown and green on green systems work as well in the dark as in sunlight?
So that's
That's
actually,
oh, go ahead. Sorry.
oh, no, you go, Terry.
No, go ahead.
They are purported to, right? So, I actually, the Weed if you go to their webpage, they actually have an image of the Weed It system at night with their blue or their red light shining down on the ground. And with the other technology, that is in part why those lights are so bright with the green on the green
Mhm.
systems is that you want to illuminate those crop rows, those bed tops, and there's so many lights is you want to illuminate it without shadows, is because that improves the detection and the discrimination ability. And
So without, go ahead.
Oh no, I was just gonna say, and I think the companies, if you go to their websites, they say like day or night operation. And I'm gonna tell you, the growers in New York that have like the laser weeder, they have two crews going. They have a crew going during the day, and they have a crew going during the evening. So those things are in operation, I think, like 18 to 20 hours.
But with no shadows, there has to be probably more careful operation at night, I would think.
I
So
think that the Will IT system is probably more useful at night than it can be during the day, because actually you're projecting light, you're projecting the blue light to elicit the fluorescence from the profile. If you can prevent during the day to get any interference, you may get better detection, because at night, if you don't have any other light interfering with chlorophyll, you can just project the blue light and get a better response and maybe better spatial separation. Now, for the green on green technology, I think yes. I mean, it doesn't matter because you're creating an artificial light environment. You're projecting so much light when you're using the laser weeder or, the Verdant robotic sharpshooter aim and apply technology, that it doesn't matter. For the weed IT, I never tested it at night, but my gut feeling is that it may work best at night. You may have better discrimination at night than during the day because you don't have any parasitic light interfering with the detection.
yeah, so now I'm gonna go ask our ask our Terry Bates out at the Clarell station. Hey, let's run a block during the day, and let's see if we can run a block in the evening or at night, and see if we get similar results. And he'll get really mad at me, but now I'm curious.
Thanks. So another question that you sort of got at, I'm not sure. So I'll just read the question. How do the costs of these precision applications compare with those of a conventional herbicide program in field crops? I don't know if that includes purchase of the equipment or not, but there's the question.
I will say that at this stage, we have not been focusing a lot. We have been mostly focusing on the effectiveness of the system. We have not been looking, neither Lynn and I have been really looking at the economic value, benefits, drawbacks of this technology. The good news is that this year, I mean, we are getting the same system. So we are getting the laser weeder, we are getting the Verdant robotic, we are getting electrical weeding working gains both in New Jersey and New York. We are repeating that this year. And this year we'll have economists on board with us. So stay tuned. We may have better news next year to let you know, what are really the economic benefits, drawback of this system. I mean, initially, we're really interested at looking at the effectiveness, but yeah, the big question that I'm getting at every grower meeting is that, okay, give us, it's working, but no, you need to give us, what does it cost on, what is the financial situation with this kind of equipment?
So some of that economic analysis for row crops is starting to come out. I believe Jason Norsworthy in Arkansas and Anita Dilley in Kansas And I think she was partnered with Purdue and Wisconsin. I think for cotton and soybean, I think those numbers are starting to come out where they're actually starting to generate, okay, here are your cost savings from a herbicide standpoint. I'm going to admit to have seen the title of their papers, but maybe not having read them in a lot of detail. But like Thierry said, this is our next step, is we are working with an economist at Rutgers to start gathering that data for the crops we work in, and that information is coming out from our colleagues who are working in field crops. So expect in the next couple of years to start to see that information.
So I just want to quickly look at the post-webinar poll, and it looks like there's a pretty good increase in knowledge. So that's really great because that's what we're after. And also quite a bit actually increase in I was distracted there in learning more about this. So we'll be calling you back for more webinars. It's very worth it.
We'll be happy to join again. No worries. We'll have more data coming after 2025 season, so we'll be happy to join again.
Yeah. So I would also argue is that Thierry and I are partnering with several with colleagues like at other institutions, at Clemson, at Oregon State, at UC Davis, at Michigan State. So we're going to have even more data following the 2026 season, and it might be really valuable to just have we could probably have a session on just electrical weeding, just precision spraying, and just laser weeding alone, as well as the autonomous robotics, because again, I hope to have much more bonsai Amiga data, particularly from the autonomous mowing this coming year.
So there's a couple more questions that are, if you have time to stay on for that. One is, can the lasers be mounted on drones to reduce soil compaction? That's in the future.
I can start and then can complement. I think one of the major issue with lasers these days is that it's heavy, it's big. You need a big tractor to get the energy for powering the laser, but not mostly for powering the laser, mostly for powering the artificial intelligence system, for powering computers that are running in artificial intelligence. And I think, even if we're making progress on drones, we don't have drones, actually field drones, that have the capacity of generating this energy. The drone's energy is mostly for lifting the drone, for making the drone flying. If you need to add energy for using artificial intelligence, for using the laser, we are not yet there. And I don't think I've not seen yet any system where they're exploring. Maybe they're exploring, but it has at least not been published. Combining drone on laser weeder. It's funny that we say that because I just sent that to Lynn this morning, but there is a paper in Europe with a new type of laser system. It's lighter, blah, 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 but it's tractor powered. It's not on a drone.
So I would agree. I think right now, all the components are just so heavy. Even if you had like a single laser, I think it'd be very heavy for the processing, the computing, the power. Now, is someone doing it? I wouldn't be shocked. Someone has got to be thinking about this, because somebody's thinking about everything out there. The other thing I would worry about with the drones is stability. I don't work with drones. I don't want to work with drones. I got enough. I'm afraid I don't even want to get into the drone space. And I would throw that to a colleague who's working on drone spraying, how stable they are, and the ability to be able to target. So I will tell you that small unit that Thierry used, the aim and apply system that was on the Amiga, that's actually a very heavy unit. With the Amiga and the sprayer combined, we tried targeting with just water, with dye in it, in our field soils at my research station. And I have a lot of rocks, and there was just enough vibration for this heavy unit where the rocks were just enough that it couldn't target properly. So I'm thinking with the drone and, air, it might make the targeting more difficult because you really have to have that stable, consistent height above the target.
There's two different angles on this, and one is the AI and the detection of the weed, and that's related to the the electromagnetic spectrum, and then the other is just the stability of the unit, and drones are not there yet, at least not the fairly lightweight ones that most people could have access to. They're good for a lot, but they're not perfect yet. And actually, one person did ask about boom stability. Would that be something that the weeder producer would address, or is that more like a tractor equipment manufacturer issue?
I think, Lynn mentioned it, regarding the aim on applied technology. I think it was stable in my field, but I have exceptionally nice field where we don't have any rocks in New Jersey. Okay, it's perfectly fine with that. I think if you're looking at bigger units, either units, you're getting more stability. So I think when we are talking about stability, it has also to do with the size of the unit. The bigger the unit, the more stability you're getting because it's heavier. But yes, like Lynn said, smaller units, either the aim on apply system or even the NIO-Os, the small robot. It's smaller, you need better stability, you need better soil preparation to really make the soil as flat as you can for optimizing the stability of the system.
Yeah, and as far as like the booms, if we're thinking say the really large John Deere See and Spray, that's that's stuff that the company is working on. That for the units, the commercial units for the vegetables that Terry and I would be working with, like the Echo Robotics or the Verdant, we're talking a 20-foot boom, which is that has all the boxes that have the camera, the lighting, and the spray technology. They're the modules. The boom stability probably really comes into with the bigger See and Spray. And I'll that's a John Deere thing. I'm sure that's all in there. I don't work in field crops, so agronomic crops. So I am not particularly versed in the nuances and all that equipment.
Okay, so another question is, do you see any attraction of and kill of non-target birds with night use? Maybe haven't done enough.
We have not seen any. I have not seen, like, if we're talking like the lasers I have not seen any non-target impacts on vertebrates or invertebrates. I haven't even seen it with the laser weeder. That was a question. Like whether it be a turtle, in the weedy vegetation or something. The only non-target impact I saw was we had aphids growing on one of the weeds, and we controlled the aphids by controlling the weed. But I have not seen anything like that.
Something very important to consider when you're talking about the laser weeder. The laser weeder is really good at killing very small weeds. If you have bigger weeds, you need more energy for killing the weeds. Basically, the system have a self, how can I say that, a self threshold where if the weed is too big, the laser will not be targeting the weed because the demand on energy will be too high. So we're really targeting very small weeds on the laser. From my experience with it has been very precise all the time. It's always targeting the meristematic area. It's not targeting the side leaves, the bigger leaf. It's really targeting the meristematic area. The only time when we saw some damage, actually, it was not on insect. It was mostly on equipment in the field. So if you have a stake, for example, which is in the pathway between the laser on the target, I mean, we got some stakes that were burned by the laser when we were targeting the weeds, but we didn't see any kind of damage to, invertebrate or vertebrate, because it's so precise. It's extremely precise.
Yeah, it is targeted technology. In fact, there's a paper, including one that Thierry and I authored with a colleague, is that the off-target movements should be dramatically reduced because of the precision with which the technology is used. And then the next thing is that, well, if we could use that precision for weed management, could maybe ultimately that laser technology be used to go against very specific, less mobile pests on crops, such as caterpillars on the leaf surface.
And the last question that I see is, one participant says they saw the electrical weeder used in an orchard, but it was not able to control weeds in between trees. How do you plan to address that?
Yeah, so
Yeah, go ahead, Lynn, because I have a problem as well.
yeah, so we do have this problem. There are some units that have like flexible swing arms that have an electrode on them that are meant and designed to go between the tree row, to flex between the trees and then flex back and then back between the trees. I do not have that unit, or the unit I have that does have that was designed for a citrus orchard, which is much larger. The spacing between trees and the way citrus is grown is much larger than, say, we have in our high density apple plantings in New York. I am attempting to work with a fabricator to get my deck altered, if it's possible, or to get the company to provide a unit that maybe would give us this ability to get, electrically weed a bit more in between the trees. But that is an issue. But Thierry and I have also talked about, we've had my graduate student has had some really good success with the very targeted application of some organic herbicides. So one of our trials this summer is to actually test the electrical weeding in partnership with like the Weed It system and the targeted application of the organic herbicides. Maybe those organic herbicides become more effective and more cost effective if we can use them a bit more judiciously. And I'm sure Thierry can talk to you his blueberry system.
No, I think you cover it perfectly well.
Thank you very much. That was the end of the questions that I saw in the Q&A. And it says there's another one here, but 365 nanometer UV light lights up tomato hornworm caterpillars extremely brightly. I'm not sure if that's a question or just a comment, but there you go. So I want to thank. Go ahead.
Oh, I was just going to say, someone brought up the UV light. We have a lot of colleagues who are looking at UV light for disease control, like powdery mildew or downy mildew control. And I think some other colleagues are actually looking, could we use UV light for weed management? There's a little bit less penetration depending on the type of UV that you're using, and it's a little bit harder, but I know people are exploring other light options, for weed control. So there's a lot going on in the weed management space beyond even what we've talked about.
All right. So I want to thank both Lynn and Thierry for this presentation. It was very interesting. And from the comments in the chat, I think all of the participants thought that as well. I also want to thank USDA and the Southern IPM Center for making this webinar possible. And with that, we'll conclude and sign off. Thank you very much.
Thank you.
Thank you, Deb.